we are only left with 16 or 14 sutras. 16 sutras, 14 upsutras. Now, for people who don't know what the meaning of the word sutra, sutra is basically a thread that connects. And essentially, anything that comes out of the Vedas, it was understood that you had a guru who would direct your knowledge. Because Vedas do not give you exact ways and means of doing stuff. They are merely guidelines. So they give you broad connotations as to, well, by the way, in this realm of possibilities, this particular equation can be applied given these principles. Now it's up to you to go ahead and explore them. And that is why the purpose of a guru in Hindu mythology or in Hinduism becomes prominent, because in Hinduism, most Vedas, not just the Vedas, they provide conflicting teachings. And it is the guru who can basically, or the learned master, who can basically direct your path to the correct understanding or interpretation of that. Okay? So I'm just going to give you a brief glimpse of what Vedic mathematics was, how it differs from what we've learned, at least back home what I learned in India, which was in early 90s and late 2000. So we look at the ancient system of Vedic mathematics, which is going to be very brief. We'll then look at the historical significance, and I don't want you to go to sleep, so I'll keep this very brief, okay? And then we'll see the application of a few sutras. This will be the interesting bit, where we do number crunching, okay? And if you're already good at maths, please forgive me, I was never good at maths. I'm a physicist, I don't know anything about maths, okay? I just use the maths to get my stuff to work. That's the level I'm at, okay? And I'm going to end with asking you a question as to what you think why this Vedic mathematics system is relevant in today's age. But before that, can somebody tell me, why do we have a love-hate relationship with maths? Sorry? Okay. Okay, I will come back to that one because I'm going to show some complicated mathematics over here. Yes, sir.
People are very what you call close to the or what you call love. They love.
Yes.
Simple love.
Yes.
Okay, but when it comes to the complex love,
Yes.
large love,
Yes.
they are really get scared, and that's why they hate
Yes. So anything.
the relationship.
So anything above 3 digits usually scared me,
Well, I don't
especially if you put the sign X between 3 digits and 3 digits.
children who are what you call can do math without what you call having a pen and paper.
Yes, that is true. That is very true.
In India, I feel that.
I hope by the end of this session you will be able to do that as well.
Yeah, I hope.
I really hope so.
I hope so. I think I have to go again.
No, no. Okay.
One thing is, because there is no logic, there is right or wrong. We can't. Logic in a way, okay.
In a civil engineering way, you mean.
I'm trying to say, like, the numbers are either right or wrong, right?
That's the logic.
That's probably the reason, like, people sometimes.
Or it's just I would say you're sort of in the ballpark. I think what you're trying to say, it's the method in which people have taught us maths. That perhaps is one of the core reasons why there's a love-hate relationship between maths. Yes, sir.
I think it involves a lot of thinking and people were not very.
Sorry, come
I
again?
think it involves a lot of thinking.
Lot of thinking, right? Lot of brain power, right? Yeah. Okay. Okay, all of those are right. Okay, and let's see by the end of these 3 sutras, you'll be able to do some complicated multiplication. Okay. People think multiplication will be easy, but no. So, stats. Let's start with stats, and I'm going to come back to this. In 1992, the government of India performed a survey. It found, not in 1992, but 70% of Indian population is youth. It's not true for 92, but 50% of that time population were youth who were very proficient in maths and science. This was in 92. Now keep this number in mind, because we are going to come back to this number, and that would be one of the causes of why we need this system. Okay. However, this is not surprising. It's higher than the average British understanding of mathematics that we've evolved with, but lower than the average Chinese. Can you imagine that? In the current survey, India ranks around 7th if you look at the GMAT scores. China ranks 1st when it comes to maths and science, which is, wow, we could have never thought that. Now, let's look at some of the historical backgrounds. How many people know the historical background of Vedic maths? How many? I mean, why would you? You don't go around reading history, right? Other than if it's Aristotle, Galileo, something like that. So, as I said, it comes from the Vedic term, the term Vedic mathematics comes from the Vedas. However, it all got burnt up. It all got lost. Nobody's seen the Vedas at the moment, right? So we are limited to what has been given to us or taught by our gurus. And slowly, across the generation, we've evolved that knowledge. Now, in the beginning of the 20th century, which was around 1911, 1918, that time, Vedic mathematics was rediscovered. The text then traveled to Europe in the 1960s in order to spread Vedic mathematics. Now, there were certain texts in the Vedas that were thoroughly ignored in terms of when it came to Vedic mathematics, because all they said was, here is how things work. They did not give any mathematical derivation of what or how or the equations. So, being the logical population that we are, we just discard them. We say, oh, there's no derivation, we don't know how it comes in, okay? Which is true. That's the Socratic way of learning, because you question. So, who rediscovered this? Does anybody know well, I've already given you the answer now. Yeah, it's already given you the answer. So, he was one of our very eminent. I personally, 5 years back, I hadn't heard of this person, right? But he was like Galileo. He was proficient at language, history, physics, philosophy, okay? And only such a person could have rediscovered Vedic mathematics, in my opinion. I don't know what you think, but in my opinion, this was the Acharya, Krishnaji. Again, we are a bit unlucky because more tragedy struck. And all the 16 volumes of rediscovery were lost again. However, what remained was few inscriptions where we get the 16 sutras of Vedic maths and the 14 upsutras. As I said. Now, the 16 sutras are as follows. Can anybody read Sanskrit over here? It's very interesting. Oh, okay. I'm not going to ask. Pardon? But can you explain the direct meaning of any one? I would like to know. Not the expert, please, just at my level. Yes, sir.
When some of the teachers from St. James Independent School
In
came to the Bhavan
in
and then took some classes on that. And I have forgotten actually, I can see the initial Navatas and Mamlashka. Entire by 9, the rest, whatever is left, by 4, Ekadike, Napurana, all these sutras.
are coming back. Yes, but the best part, my question was more broad. It's like, these are just sutras. So if you look at the English translation, the first one is, by one more than the one before. What does it mean? Like if I give you this sutra, you gave me this sutra, I would be like, how do I apply this? Right? Does anybody have a clue how they applied it? Oh, you're actually analyzing it. No. So let's see how you apply these sutras. So we'll only cover the first three because I don't want this to become a maths lesson where I have to explain division and decimal point. Okay? So let's stick with basic addition and mathematics, addition and multiplication. Nothing more, I promise you. So this is the first sutra. Ekadikena purvanena. By one more than one before. Now, what does this mean? Now, this sutra, if you see, this sutra can be applied to three branches. One is the addition, the other is the subtraction. But the most interesting one, that maybe you like it over here, is the squaring, specifically for numbers ending with 5. Do you guys know the trick? For anything ending with 5, how do you calculate this? So so mathematical questions of Vedic mathematics. Now you'll be amazed to know this. So when I was completing my university, I interned for a bank, and I interned for their trading floor, unfortunately. And almost every question they asked me finds its way in Vedic mathematics. The first question I was asked is, what is 75 squared? Like, walk in the door, I don't even sit. The first question they asked me, what is 75 squared? And it should be like that. And I'll tell you how. Sorry? Yes, but okay. 5265. Yeah, okay. So 25 squared? Okay. But the Indian way, how we learned with across with those. Yeah. But that's the beauty of Vedic mathematics. You only need up until 15. And you can do every sort of multiplication, any sort of permutation combination.
Our teacher, by the end of the day, he would say, okay, last half an hour, everybody will just count recite the table. So whoever is not giving the correct answer, he had a stake.
Oh, wow.
We learn it. We learn it then. So
Okay.
it used to be like, I'm talking about 70s and 80s.
Yes, we weren't that disciplined, unfortunately. Okay, so you remember in the school we had those copies with little squares, and we had to make sure we write the numbers within those squares, and we absolutely did it this way, right? And then we had a little X, okay, and we came up with this. Yes. It gets partitioned even more. Oh, wow. What I'm going to show you is going to blow their mind then. So that reminds me of my computer teacher. I went back. I was about to pass the exam, and he cut 3 marks, so I didn't pass it. Okay, and this shouldn't be on record. Sorry. So my one answer that I went to him with was like AB plus BC, and all I did was I said A plus C brackets B. So he said, no, I'm going to fail you for this. You know why? Because I have to simplify, not complexify it. So now let's simplify the issue. Okay? How do you look at this number in Vedic mathematics? 25 squared. You divide it into 2 parts. You take the 5 squared, which is 25. You add 1 to 2, the first digit and multiply it with it. So 2 times 3, and that's your answer. Okay? Sorry? You just add the first digit. So 25, the first digit is 2. You add 1 to 2. That's the first sutra. The sutra in itself, yes. So the sutra in itself talks about, I'll go back. Yes. Ekatikena Purvena. Yeah. And this is what the problem with sutras is. People, you have to read it very carefully, and then first task is to read it carefully, second task is to apply it. But two different worlds. Okay. So that's fine. This is easy. Now everyone finds it easy. I should probably go home now because you guys know mathematics. Okay, this is how we used to do it. Okay? $25? 8 sevens are 56. That's what the answer is. I mean, I would say that exact thing to my school. I was almost there. I was almost there, sir. What about this? This should be easy. It shouldn't take you this much time. 10925? No. Perfect. This is going to be a short presentation. Trust me. Okay? So look at the left-hand side. How much work do we have to do? How much work actually I did, because I was not good at maths. Okay? And look at the elegance of the method on your right-hand side. I mean, you don't even need to do the calculation. What about this? 12 times 13. 15625. So you guys now can do any 25 calculations, most likely, right? Let's go on to the second sutra. I'm telling you, this is going to be a short lecture. I don't know you guys are going to be so well. I would have prepared all 16 sutras in this way. But let's look at it. This is actually the second sutra, which is the most interesting to me. Look at the English translation. All from 9 and the last from 10, as mentioned. Okay. So the trick over here is to consider the base, and that's it. You basically look at the number, how much away from the base that number is, and you follow a process. Okay, but how do you apply this? So let's consider base 10, the simplest of everything. You don't need it. This is multiplication table. We all did it. But how does the sutra apply? So how far is 7 from 10? 3? And 8? Okay. So all you do is you multiply 3 times 2, which is? So you get the first part of the answer. The second part of the answer is you either subtract 2 from 7 or 3 from 8, which is the same thing, isn't it? Because 7 minus 2 is 5, 8 minus 3 is 5. And that's your answer. Let's increase the complexity on this. This is going to be very easy for people over here. What about this? Using the sutra, not the multiplication table that you've learnt. So how far is 14 from 10? Plus 4. Plus 2. So you multiply 8. And what else? What do we do next? So we do either 14 plus 2 or 12 plus 4, which is the same thing. And that's your answer. What about this? What base do we take over here? you're making my life difficult. Please, please, at least say 10 so I can correct you and say no. Please say 100. Yes. What about this? Yeah. 9310. Now do you see the complexity as what you were talking, sir?
Exactly. Then the head comes in.
And then you start enjoying
Again,
this.
what you call, what happened with older teachers at
Yes.
that time.
Yes.
I'm talking about before 60.
Yes.
They were not teaching like what you are teaching now. They were teaching with the head, with the stick in their hand, as you say. So, that was the fear. So you're not really learning with love. You know what? That Vedic time
Yeah.
had no love. There was a stick in the teacher guru. The guru had a stick.
Oh,
And
they.
used to hit.
But
That is
then,
not right way of teaching.
but it can be argued that in the Gurukul, the Guru always had a stick.
No, no. Actually, it happened to me. I don't want to say that.
Okay.
Example.
No, let's not
It
go there.
happened to me.
Yes. Okay. Let's not go there.
Can I ask something? So you said the sutra said all from 9 and 1 from 10. So on the example you just given, where's the all from 9? I don't understand.
Sir, go on. Go on. No, no, go ahead. Go ahead. No, 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 no.
I understand what you've shown us.
Yeah.
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 I did that one before. That's
Yeah.
awesome. But I never, that's why I'm confused. I don't understand how it relates to all from 9 and 1 from 10.
So 1 from 10 means
9.
and all from 9. So you look at the base as 10.
2 ways of saying the same thing. Is that
Exactly, that is what I said initially in the sutra. The problem with Vedas is there are a direction and they don't tell you exactly what needs to be done. They tell you, well, this is the general way of looking at it. I'm only going to show you those numbers with 2 digits. But if you expand this to 4 or 5, that sutra still applies. And so they're not talking about one particular instance, they're talking about the breadth.
So you think that was the base 10 of the decade?
Yes.
And
So one of the basics of Vedic mathematics is it finds basis from Vedic astrology as well, where people had to do fast calculations. Well, they had to understand angular calculations of the day as to where the sun was given a particular time. And they would make charts of that instance. For example, when you asked me the question, in the olden days, even now, there are some Vedic astrologers who make the astrological chart of that instant of time that you asked me the question. Yes, and then they give you the answer. And that is why, I don't know how many people have watched the old Indian shows where a king enters and enters into a sage. A sage is meditating under a tree, and king goes and touches his feet. And the sage says, "Oh, I know why you are here." But how do you think they knew that? Because they knew exactly the time of the day where the sun was, and they knew exactly what the astrological chart of that instance would be. And they would find the question that that king came in for. So that was so the sutras don't just cover the instance, they cover the breadth. So it's very difficult to answer that question to some extent. Sorry, that's a roundabout way of saying. It's difficult to answer. Okay? So it's not just the instance, it's the breadth. Now that you guys have had a break, what about this? 96 times 85. No calculators. Come on. I don't know. Maybe 10. Should we take 10? Should we take as 10 base or 100? Okay. Eight one. Okay, let's see. Wow. How many incidents, how many seconds was that for everyone? Could you have imagined before you entered this room you'll be able to do this calculation? No. Oh well. Okay, now comes the fun bits. What about this? I mean, anyone who works in finance or is looking for a job, this is ideal to end.
70 was 2 is balance. So 136, 138, 138,
Let's see. So base is 100 plus 15 plus 16. Oh, sorry, my mistake. It should be 116. No, your answer is right. I made the mistake, so I'll correct it. Thank you. Yeah, the teacher has been scolded. Let's start again. Okay. Plus 16. Okay, now where's the trick over here? Because there are 2 digits. 15 times 16 is not 2 digits, 3 digits. Oh, base 10. Or you want to do the base 10, but I know. I was going to go bring that in the next slide, but you ruined it. Thanks. No, just kidding. So that's 131, right? But now we add that too. How many seconds does it take for someone to do this now? If I would have known this, I would have done a lot of things, in maths at least. But maths was really terrible. Perhaps you're right. Are you guys understanding this? How easy it is? The elegance of the process? Vedic maths? Okay, I'm going to give you some time to do this now. Yes, the sutra says 10. You have a paper pen? Do you want to do it? No? No, no, you should, because if you can use a paper pen and arrive at the answer, that's good enough. You don't need to have mental tricks for everything. Okay. I'm going to give you 2 minutes. I'm going to quench my thirst for a bit. There's a simpler way. Think simple. There are simpler ways. Vedic mathematics depends on the whole idea of you not racking your brain. Simple. Okay. But you see, that's the issue. So now let's take the base as 100 again. Okay? Now can you go through it? Is that easy? I need to write that down. Yeah? $10,000? Yeah. Slowly carry it over. Hang on. Give us a sec. But now, how do you carry that over? That's the trick. There are only 2 digits. You can't carry over more than 2 digits. So carry over only 2 digits. Yeah? And we carry over 84.
Where in the sutra does it say that carry over these two?
My point exactly. You have to carry over because you only have the units and the tens. There's no hundreds over here because because the difference from base 100 is in units and the tens, 86, which is only 2 digits.
That's where your guru comes in.
Kick, yes. I would say that. I mean, yeah. I mean, in those days, of course, he would ask you. Yes, sir. Yes. I'm going to come to that. 3, yes. Yes. So you can go 3, and then I've shown, well, yeah, it's spoiling the fun. Now there's base 1000, base 100, base 10, and then you backtrack the entire thing. But it's easier than going through the entire of multiplying by putting x's and then subdividing it. It's more fun, I think, because over here you're actually applying your brains to do the thing, because some people can multiply 86, 98, some people can multiply 14, 15. So it caters to each and every possibility. It's more flexible. Pardon?
That's how you used to doing the multiplication,
Yes, the one I showed.
they're so used to that. So when you bring this concept in, it's going to be like, oh my God, we can't do this. This is too complicated.
Is it?
That is, so if I bring this into my classroom, I know that's.
You're a teacher. Oh, wow.
So I'm teaching adults maths.
Okay.
And the whole reason I'm here is because I want to see how I can make things easier for them, because there are adults who come back to maths who haven't done it for years, who absolutely hate it. So getting them into the classroom requires them to dance. So they actually come in. Let's put it like this. But anyway, I've got them in. But I know that when they see this, the initial reaction is, oh my God, can we go back to? So this will need some practice. It's slower. It's, yeah, more examples. Once you get it, it's so much fun. It's so much quicker. It's so much more fun.
It's way quicker.
Absolutely great.
Most of my friends who've cracked the critical exams that you have to require to go to, not business school, but in India you have to, if you attend the IITs, most of my friends who've attended IITs, they knew Vedic mathematics from, I think, age 6, 7. And they were brilliant at maths. They were about a year and a half ahead of most of the class.
Yeah, maths teacher, when she taught us this, but this is years ago.
There we go.
Just one teacher.
So base is 1000. Okay. This is easier. Oh, now everyone goes like, this is easy. Please give us a more complicated problem. Please give us differential calculus or something along those lines. This is now too easy for us. Is 4 numbers, then the base will be? If there are 4 digits. No, if there are 4 digits over here, what's the base? 10,000. 10,000. But if it's that close to 1,000, then you don't need another branch. Okay? You can just simply do that. Because the closer it is to 10, the closer it is to the base, the less branches you need. Okay? That's the trick. The further away, so it sort of exponentially goes up. So the moment you go to the 80s or 70s you need at least 4 branches. For 80s, you need 2. 2 will be okay. 90s, you just need one. So it's indirectly proportional. Or directly proportional. Is that? Which one? I don't know. I think this should be easy. I don't know why I put in complex. Okay. Yes. Now comes the. Let me just introduce the three bases. So the branches. Please go ahead. Enjoy.
You were waiting for that.
Yes.
You were like the easy one.
Putting us all on the
So I've given you the answer. It's like you can branch out to base 10 as well. I deliberately chose only 3 sutras because I don't want to increase it to differential calculus. Maybe a different lecture would be for that. Okay. Okay, let me slowly give you the answer. Drip feed it. You know, you've got a notepad in your phone. You can start using the notepad. Oh, right, okay. Somebody's using it. Good. Oh, there are 2 young boys doing the Vedic maths calculation over here. That's interesting. Yeah. Why not? Why not? Okay, I've given you the answer now. Come on. This should be easy. Okay, let's go through it. You know, let's go through it. Okay? 182? 182 sits over there. You can reduce the tens also further. You can reduce the 4. Well, I've gone to base 10, but yeah? Okay? So what are we looking at over here? 12882. But remember, there are only 3 digits. That is 5 digits. So what do? And that's 773. So you carry forward the 12. And that's your answer. I have to be very careful with numbers on the screen. It's embarrassing when they go wrong. Yes? I should go back. Yeah, that's fine. I mean,
I just added
I have to go down to the base 10 because I can't do it. So I've just shown how the calculation works, nothing else. Well, easiest depends on. Yeah, I'm not that bright. I need more space to go through. Like, yeah, I just, well, yeah. Sorry, humbleness goes somewhere. Yes, sorry?
You can use this concept when the numbers are closer to the base, and then you can use the nominal way to multiply.
So look at the difference and look at how close is that to the base.
Yeah.
If it's further out from the base,
Then use the
branch it out further. So 114 is further out 14. Some people, I wouldn't branch it further, but some people would want to branch it. So you have the option to branch it out to base 10. Okay? Yes. So you can branch it out.
Like see, then like you can also do that way.
You can do it that way. Yes. Now, I promise third sutra, nothing more. Okay? Just one sutra more. But this, I'm not going to give. Yes, but it'll slowly spiral out of.
It's what is the time now? It's 7:30 and the brain is still working after the whole 8 hours of work. So
Again, so this sutra, it's more to do with vertical and crosswise. Again, multiplication, very basic. Okay? And this you're trying to multiply any number. Any number. And you can get that. You can apply this to any number. Okay? Now, what do you mean by vertical and crosswise? So vertical is 12 times 34. So you go vertical, which is 8. You don't add. And then you go cross, but add both the crosses. So you add the products of the cross, which is 4 times 1 plus 3 times 2, which is 10. 6 plus 4. And then you go vertical again on the other side. So that's 3. Because there's 10, you add the 1. So you add the products of the cross, and if that product is greater than the digit, you add the tens digit to the further out number. Does that make sense?
It makes a sense, but I think this is not the methodology which was used in the calculation, functioning of the calculator, or the engineering of the calculator.
Oh no, that's totally different. That's not, that's,
Exactly.
I mean,
This is
that's,
now what you call the Vedic mathematics just left behind.
perhaps because the olden day sages didn't have calculators, they didn't have places to write.
These are older,
Yeah,
but it was not based on that.
but they didn't have places to write as well. So they had to, and they didn't have places to write and store because, yes. So in effect, they wanted to reduce the complexity to a level which is digestible to the brain at that time. And that is where Vedic mathematics is. Okay? Now there are 14 Upasutras. Okay? And I'm going to cover one of those. Just one. Okay? Only the last terms, ma'am. This will be a bit more confusing. Only the last terms. Now you can solve certain equations, remember, certain equations where the numerator and with the numerator and denominator without the independent terms on one side are in a ratio of the entire numerator. In effect, this is talking about multiplying any number by 11. Okay? 11, yes. And let's go back to the traditional way of doing things. Yeah? Can somebody tell me how can I arrive at 352 from Vedic mathematics principle? It's more simpler. 3? Oh no, it's more simpler than that. You guys are going to laugh me out if I say how simple it is. Okay, here's the way to do it. You branch out the numbers, 32, so 3 and 2, And the second step is add them. And that slots in the middle.
This is only relevant for EMEs.
Yes. And this works across the board for any number. Doesn't matter. What are you multiplying by 11? It works across the board. Disclaimer, across the board is how much I've tested. Sorry? What about this? This is fine? 495? So easy. So easy. Everyone is a mathematician now. 75? What about this? How do you get to 825? Wow.
You got a very bright audience.
It's always the audience. It's always the students who are bright. Teachers like, "Meh." So one carries over. Absolutely right. What about this? So if you understood the first, you should be able to solve this. If you learn the first sutra, then you won't be able to solve this. That's the test.
That's the first sutra where you use like one more, isn't it? That's it.
So you're almost there. You just didn't do the other side of the equation. That's the way. So it goes both ways. Yes? Any questions? No. So now let me come back to that original point, and this is the concluding bit where I make the case for why we need Vedic mathematics. So in the original slides, you noted that 50% of all Indian population in 92 were proficient at science and maths. That dropped to 37% in 2008.